Okay, now I'm going to show you how you can solve these two exercises. Let's start with the first one. So this is exercise number 1 and this is exercise number 2. We'll start with the first one, that is classifying a given image. And you are also told into 3 land cover types. So how can you classify a digital image? We have said earlier that a digital image contains digital numbers. Based on digital numbers, we can categorize different pixels and we can change them into teams or classes. And another important issue is you are given a spatial resolution of 80 meters. A resolution is defined in a pixel. Spatial resolution means the size of a pixel in terms of area. So the distance is 80 meters. It is 80 by 80. So given this 80 meter pixel resolution, you are required to categorize into 3 land cover types and calculate their area coverage. So how can you create classes? It is based on the closeness of a pixel value to another pixel value. For example, if you compare 80 and 6, more or less they are similar. And if you compare 40, 45, 49, more or less they are similar, so they can be categorized as one class. So this pixel is similar with this pixel than with this pixel. So this pixel is rather similar with this one, this one, this one. So we do have 1, 2, 3 classes into one class, and 1, 2, 3, 4 pixels into another class. So we can say class 1, it has 2 pixels. Let's call class 1 this 2 pixels. And class 2, how many pixels? 1, 2, 3. 3 pixels. And class 3 can be these 4 pixels. 1, 2, 3, 4 pixels. 4 pixels. And we know the area of 1 pixel. 1 pixel has got an area 80 by 80. So area for 1 pixel is 80 meters by 80, which is 6,400 meters squared. So 2 pixel times 6,400 meters squared. 3 pixels, 6,400 meters squared. 6,400 meters squared. So this is the area, you can calculate it. Okay? So let's go to question number 2. So taking land cover maps, there are 2 land cover maps. This is a land cover map developed from classification, and this is a land cover map developed from field verification. That is ground truth map and classification map. By comparing these two, you are requested to calculate producer's accuracy, user's accuracy, and overall accuracy. So G refers to grazing land, W refers to water body, F refers to forest land. So compare these two and develop an error matrix. So as I told you earlier, an error matrix is what? It is a table. It is a table which compares classification result with, this is a ground truth result and this is classification result. So you have grass 3 classes, grass, forest, and water. And finally, you will have a column total. And grass, similarly, forest, water. And you have row total. So this is an error matrix. It is a table which compares classification result with ground truth data or result. So filling this table will enable you calculate these three matrices. So how many pixels do you know grass in the classification result and grass in the ground truth result? So you do this pixel by pixel. For example, this is grass in the classification. And how about this pixel in the ground truth? This pixel and this pixel are similar in location. So this pixel grass in classification is also grass in ground truth. This grass is also grass in the ground truth. So there are two pixels which are grass in grass. So what about grass in the classification and forest in ground truth? Do you know any pixel which is grass in the classification and forest in the ground truth? There is no pixel. There is no such a pixel. So what about grass water? These two are grass. And the third one, when you go to the ground truth classification, it is water. So there is one pixel which is grass in the classification, but water in ground truth. So you have one pixel. The row total is. What about forest grass? There is no pixel. These two forest pixels are also forest in ground truth. So there are two pixels. What about forest water? There is no forest water, so you have two. Water, grass. Classification result, water. These are 4 pixels in the classification. What about in the ground truth? Only one of the pixels in the ground truth becomes grass. So it is 1. Water, forest, there is no. What about water? This pixel, if you check them on the ground, they become 3 of them are water. So 4 pixels. So now let's add this. Let's make column total. 2 plus 1 is 3, 2 and 4. The total number of pixels is how much? 1, 2, 3. 1, 2, 3. 3 by 3 is 9. 3 plus 2, 5. 5 plus 4 is 9. Okay. Now let's first compute the overall accuracy. The overall accuracy can be calculated by the summation of the correctly classified pixels over the total number of pixels. The correctly classified pixels are the diagonal elements. Okay. So how many do you have? 2 plus 2 plus 3 over 9, which is 7 over 9 times 100% is overall accuracy. Okay. What about producer accuracy? Producer accuracy can be calculated from the correctly classified pixel over the total, the column total. So producer accuracy for grass, for forest, for water. For grass, it becomes 2 over 3. 2 over 3 times 100. For forest, 2 over 2. 2 over 2 times 100. For water, 3 over 4. 3 over times 100. Similarly, we can compute user accuracy. User accuracy is calculated by comparing the correctly classified pixel versus row total. So for grass, for forest, and for water. For grass, 2 over 3. 2 over 3 times 100. For forest, 2 over 2 times 100. For water, 3 over 4. So you have how many matrices? 1, 2, 3, 4, 5, 6, 7 matrices. So if you are asked to develop an error matrix and compute the error matrix, indirectly you are asked to calculate 7 error matrices. okay, matrices. So that's it. Thank you very much.